Okay, this projectiles question is looking at a crate that is being dropped from a plane that has a horizontal velocity of 95 meters per second. So the first part of the question is to ask you to sketch the path it's going to take if it's dropped at P and lands at Q. Well, since it's a projectile question, we know that the only force acting on it, we're told we can ignore air resistance, only force acting on it is going to be gravity, which is going to accelerate it. And so this means that my path should have equal distance in the horizontal for each time interval, but an increasing distance in the vertical, because it's going to be accelerating downwards, but going constant speed in the horizontal. So what we want is a curve with an ever increasing gradient as we get towards Q. And that would get you 1 mark. The next part of the question, since all of part A is worth 3, this would be worth 2 marks, is asking to explain why the horizontal component of the crate's velocity remains constant. Well, we're ignoring air resistance. So if there's no air resistance, and remember, when we have these explain answers, we always have to use the right physics. Why is the lack of air resistance not going to slow down the crate? Well, if there's no air resistance, there is no force in the horizontal. Since F is equal to ma, no force equals no deceleration, which equals constant speed. So the second part of the question says that if the crate's not going to be damaged, the maximum vertical velocity can be 32 meters per second. Show that the maximum height we can drop it from is 52 meters. Well, for all of these show these, what we're trying to do is say, okay, I'm going to work out, using my maximum impact vertical velocity of 32 meters per second, I'm going to work out what the maximum height I can drop it from is and compare it to that figure. So in the vertical plane, I've got my object. It's falling with an acceleration due to gravity, which is 9.8. Its initial velocity is going to be 0, and we're modelling it with an impact velocity of 32 meters per second. So we write our SUVAT out and write what we have. S is what we're looking for, that's our displacement. U in the vertical is 0, V is 32, A is 9.8, time we don't have, so we need to select the correct equation. We have S, U, V and A, so we'll use V squared is equal to U squared plus 2AS. We know that the U squared is going to disappear since U is 0. So therefore 32 squared is equal to 2AS. So our S is equal to 32 squared over 2 times our acceleration of 9.8, which gives us 52.2 meters, and that is approximately 52. Then it says calculate the time taken for the crate to reach the ground if it's dropped from a height of 52 meters. So this means that we again are selecting our appropriate SUVAT equation. We know that, and it's wanting to know the time taken for the crate to reach the ground at a height of 52 meters. So we have got our S is equal to 52, our U is equal to 0, our V, technically we know it's about 32, but we don't know it for certain what it is for 52, so we'll put that as a not known. Our acceleration is 9.8, and our time is what we are looking for. So again, we select the correct equation. For this, we're going to go with S is equal to UT plus a half AT squared. That's got all the things that we know in and the thing that we're looking for. UT is going to disappear since U is 0, so S is just equal to a half AT squared. So we can rearrange this. T squared is equal to 2S over A. Therefore, T is equal to the square root of 2S over A, which is the square root of 2 times 52 over 9.8, which gives us an answer of 3.26 seconds. And we'd probably, given that everything else is given to 2 sig figs here, round that up to 3.3. Then, if R is a point on the ground directly below P, calculate the horizontal distance QR. So basically, my package has done this. Here's where it was released. Here's point R. Here's point Q. And we're wanting to work out that distance there, S. Well, because this is in the horizontal, we don't need to model our SUVAT. When it's in the horizontal, because there's no force acting on it, we can just use speed is equal to distance over time and rearrange for what we're looking for. In this case here, distance is equal to speed times time. Or if we wanted to put it in SUVAT, S is equal to V times T. We know the time of the flight. We worked that out in the last part. So all we have to do to find the distance is multiply that time of 3.26 by its velocity, which was 95 in the horizontal. And that gives us an answer of 310 meters. Then for this last part, which is worth 2, and it's another explainy one, in practice air resistance isn't negligible. State and explain the effect this has on the maximum height from which the crate can be dropped. Well, we're told that it can be dropped from 52 meters because its maximum impact speed in the vertical can only be 32 meters per second. If air resistance did exist, if we did have to take that into consideration, then it would produce a force countering gravity. Therefore, the acceleration due to gravity will be less in the vertical. Therefore, it's got a greater time to fall before reaching (32 meters per second). And the effect of that is to increase the height. So we've got our state here, it increases the height, and our reason. Air resistance is going to produce a force that's in opposition to gravity, therefore the acceleration on it is going to be less. Therefore we can drop it from a greater height before it will hit that maximum speed.